Okay, so section 1.2, ordered pairs as points. Okay, so the first couple things I'm going to have you write down are some definitions. Ordered pairs, not really a definition, but what you kind of need to know about that is you're always going to have an x and a y. Your x is going to be horizontal, so your x direction when you graph is always going to be right and left, and then your y is always going to be vertical, so it's what you do up and down. Okay. Now these other ones here you probably have to look up in the book. So plane coordinate geometry on page 13, standard form page 13, Euclidean plane geometry on 14, and then we'll stop there and I'll talk through those. So get those jotted down and then I'll talk through what they mean. Okay, so the first one, plane coordinate geometry on page 13 says, when I flip to it, it says the study of geometric figures using points as ordered pairs of real numbers is called plane coordinate geometry. Okay, so coordinate geometry is basically when we use things like a graph, kind of like here. This is a coordinate plane, so they're talking about anytime we use ordered pairs and make lines and do that kind of thing, that's Euclidean geometry. And basically Euclidean geometry is the kind of math that you would think of in general. It's nothing that's different. It's kind of what you've been using probably your whole life to do math. The next thing there, standard form, it's just a certain way to set up an equation. So standard form is where you'll have a number here for a that goes with the x, so a coefficient, so it could be like 3x plus, and then b would be a number as well, so maybe 3x plus 4y is equal to, and then c is also a number, maybe 5 or something like that. That would be standard form. Next one there, Euclidean plane geometry, or plane coordinate geometry, it says, this is again where it says our description of our point and description of a line. So for that it says a point is an ordered pair of real numbers, okay, so kind of like what we talked about before, ordered pair, your x and y. And then description of a line is a set of ordered pairs of real numbers, x and y, satisfying an equation in the form, and then it lists out the standard form again, where a and b are not both 0, okay? And if you think about it, why they say that there, well, if a is 0 and b is also 0, well, 0 times anything is 0, 0 times anything is 0 there, so that would just be 0 is equal to, and c is another number, so maybe 0 is equal to 5, well, that doesn't really make sense for a line. So those both can't be 0 at the same time. Now one of them could be 0, and that's kind of what happens down here with this next thing. So on page 14, there should be 3 pictures kind of towards the top of the page where they've got one that's a horizontal line, one that's a vertical line, and then one that's an oblique or like a diagonal line. I would jot those into your notes and then also put the equation that goes with it. So like the first one for the horizontal, I would just sketch something kind of like that for my graph, and then maybe you want to do like in a different color the line that they're talking about. So that would be a horizontal line, and then where they get their number for like the y equals, they have 1.5 there for theirs. They're getting that from where it crosses that line right there. So where it crosses the y-axis is where they get that number. Okay, and then for your vertical one, for the next one there, again, I would just sketch it. You know, something like that, and they have, what do they have? X is equal to -3. So what that means is that's going to be a vertical line through -3. So that point right there is -3. Okay, and that point right there is 1.5. Okay, so that's kind of how they're coming up with that. Now an oblique line would just be kind of a diagonal line. So it could go any way. What ways theirs go? Oops, I didn't draw the other one in, did I? An oblique line would just be something that kind of goes diagonal, wouldn't be horizontal or vertical, and then it's going to be written in standard form, something kind of like that. So they've got listed is x plus y is equal to 3, but in any case, as long as there's both of those variables there, x and y, then it's going to be an oblique line. Okay. So the next thing here, slope-intercept form. So this is the one that I probably most commonly use, and there's probably a definition for it in the book too. But slope-intercept form is where you've got y is equal to mx plus b. Your y-intercept is what the b is. So when they're talking about y-intercept would be where it crosses the y-axis. So like back to this graph here, wherever it's crossing right there, that's your y-intercept because this is the y-axis. So wherever that diagonal line or whatever kind of line is crossing the y, that's your y-intercept. Okay. Now your slope is your steepness. So like how far up and over you've got to go, and if it's like super steep or if it's less steep, and then which direction it's going as well. Because this would be a negative slope because it's going downhill. If we had a line going that way, that would be a positive slope, and we'll talk about that kind of down here. But that's slope-intercept form. It's always going to be y equals. Then your m is always going to represent the slope. Then the slope is always going to be with the x, and then it's always going to be plus your y-intercept at the end. Okay, and we'll do some problems related to that as well. Okay, to calculate slope, what you want to do is it's the change in y over the change in x. Okay, so change, to calculate change or difference, we would subtract. So you're going to take the difference of your two y values, so y1 and y2 from the ordered pairs, and you're going to subtract those on the top. Then to figure out your bottom number for the fraction, you're basically going to take your x's and subtract those. Now why they have 1s and 2s with them, it doesn't, like the number doesn't matter. What they're telling you is that these two are grouped together, so x1 and y1 are grouped together. So when you put them into your problem here, they've got to be stacked together. Okay, so if you start with this ordered pair, the x2 and y2, you have to like keep that together as well, like stacked on top of each other. So if you start with, you know, the second one, you also have to start with the second one on the bottom. And you can start with the first one as well. It doesn't really matter. Usually books write it out like that, and I have no idea why. Okay, next thing, another way to look at slope is your rise over your run. So now when I'm talking about that, so say I've got a line like that, and I've got a point right there, something like that. Okay, so now when we're talking about rise over run, say we start at this point here, we're trying to figure out how far we rise and how far we run, and that would be slope. So now if we're going up and to the right, that's going to be positive. Now some graphs you'll run out of room doing that, so you'll have to go the other way, but if you go down and to the left, that's also positive. Okay, now why that works is if you go up and to the right, up is positive, right is positive. So if your rise is a positive number divided by a positive number, you're going to get a positive answer. Okay, same with here. If we start here, we go down, down is negative. If we go to the left, that's negative. So if you do a negative divided by a negative, that also comes out to be a positive answer. Okay, so that's how that works, that you can go both ways with that. Now a negative slope, so I'm going to do it down here. Am I going to do it right there? I'll do it over here. So negative slope be going that way. So again, you got your points there. We'll go off the middle one. So with this, if we do rise and run, our rise, see how far we go up, and then our run, see how far we go over to the next point. Well, if we're rising, it's positive, and if we go to the left, that's negative. Same thing here, if we start at that middle point, go down, well down is negative, to the right is positive. In this case, our rise, positive, so we do positive divided by a negative. That always comes out to be a negative. In this case here, our rise is going down, so a negative divided by a positive, that also comes out to be a negative. So in a case like this, when we're going downhill, that's always going to be a negative number. Okay, so that's kind of how that works out. But positive, always going to be uphill. Negative, always going to be going downhill. Okay? Alright, so the next thing they want us to do here is to graph an equation. So we've got y is equal to 3x plus 1, and this one's good to work with because it's already in slope-intercept form, and slope-intercept form is really easy to graph out of. Well, not really easy. It's really easy after you practice it for a while. Okay, so we've got y equals, and we know, thinking back to that equation before, when we've got y equals mx plus b, the m is always our slope, and the b is always our y-intercept. Okay, so in this case, our y-intercept, or our b, is going to be 1. I'll put that here. Our y-intercept is 1, and our slope is 3. And typically when we work with slope and we're going to graph it, usually you see it as a fraction, so your top number is your rise, and your bottom number is your run. And you can always take a number, so if it's a whole number like that, like 3, you can always take and put it over 1 to make it a fraction. Okay, when we graph, we always start with the y-intercept. That gives us a starting point to do the slope off of. Okay, so what we're going to do is we're going to go to our y-axis, which is our up and down one, and we're going to go to 1, stick a point. Then we're going to do our slope, so we're going to have to rise up 3 and run 1 to the right, okay, because right is positive. So we're going to rise up 3, so 1, 2, 3, and then we're going to run 1 to the right. Okay, and then from that point we just made, we could do that again. So we rise up 3, 1, 2, 3, and then go over 1 to the right. Okay, whenever you're graphing lines like this, you want to do at least 3 points, because 3 points makes a good line, and just to check yourself to make sure that you're doing it right. And you can also say, you know, we went to do that again, maybe we ran out of room doing it that way. We could also go down. So if you go down, that's negative, so 1, 2, 3, then you would have to go left, because if we rise negative, so like if you went down 3 and then you go to run, well, to get this back to a positive slope, which it is, you would have to go a negative, because if you do negative 3 divided by negative 1, you still have a positive 3, so your slope is still positive 3 there. And you could do that again if you wanted to, down 3, 1, 2, 3, left 1, and then all of those points should connect into a straight line. And if it's not a straight line, then something's wrong. Okay, try another one here. Okay, so this one, it says write an equation of the line that contains the points 4, 2, and 1, 8. Okay, so they just give us points on a line, and we've got to come up with an equation for that. I typically like to work with slope-intercept because I think that's the easiest, and usually it's the only one I can remember. So we're going to have to come up with the slope, and we're going to have to come up with the y-intercept. Slope is the easiest thing to find first. Okay, so what we're going to want to do is we're going to want to use that slope formula, which was the y2 minus the y1 over x2 minus x1. Okay, so it's always the y's on the top, and that's a big mistake that people typically make, is they want to put the x on top because it comes first, but always remember that it's rise over run, and the y is our rising. Okay, so our ordered pairs here, we got 4, 2, 4 is the x, 2 is the y, and then 1, 8, 1 is the x, 8 is the y. Okay, so if I take and I plug that in there, so y minus y, so if I pick, say I pick this y first, 2, so if I did 2 minus my other y, which is 8, over, and then if I chose the 2 first, I have to choose the 4 first, okay, that's important. You can't just choose the 2 and then flop over to this one. If you choose the 2 first, you've got to choose the 4 first. So then you do 4 minus, and then your other x is 1. Okay, and then if we solve that out, I always like to turn my subtracts to adding the opposite, which you don't have to, I don't really care, but it's easier for me. So then I do 2 plus a negative 8, which would be negative 6, over, and then here we would do, really I probably shouldn't have switched this one from subtract, but 4 minus 1, or 4 plus a negative 1, would be 3. And then if you take and simplify that down, well, negative 6 divided by 3 would come out to be negative 2. So your slope in this case, and I should have put an m here, our m, which is slope, comes out to be negative 2. Okay, so we're part way to getting this figured out here. Okay, so now if we go back to our equation here, so y equals mx plus b, well, we just figured out our m was -2, so we can put that in there. Now we're trying to find our b, and we need some x's and y's. Well, we have x's and y's because up here in our ordered pairs, you know, there's an x and a y with each of those, right? So we can take one of those ordered pairs and plug it in down here to be able to figure out what the b is. Okay, so if I take my 0.42 there, well, I know my x is 4 and my y is 2, so my x I'm going to replace with a 4 from up here, and then my y, same ordered pair, I'm going to replace that with a 2, and then I'm going to drop my plus b down. Now I've plugged in for everything except for the b, and now I can solve for the b. Okay, so if I solve that out there, if I took -2 times 4, that would be -8, plus b is equal to 2. And then we remember when we're solving equations, we want to try to get the variable by itself. So to get rid of that -8 there, I would add 8 to each side. That goes away. So on the right side, you'll be left with b. And then on the left side, if you do 2 plus 8, you should get 10. Okay. Now I just solved out all the different things I needed to know to be able to make an equation. So now my final answer would be y equals, it's always going to start with y equals, my slope is -2, x plus my y-intercept I figured out to be 10, and that would be my answer. Okay. Now we also could have used the other point there. You didn't have to use 2 and 4. You could have used 1 and 8 and got the same answer. So you could have plugged in a 1 for the x and an 8 for the y, and when you solve it out, you would still get 10 here and 10 for your answer there. Okay. Alright, so the next example we're doing the same exact thing. Okay, so we got to find our slope by using those 2 points, and then we're going to have to find our y-intercept to make our equation of the line. Okay, so we've got -3, 3, and 6, 6. I usually write an x and a y with those just because usually I get flustered in the problem and forget what I'm doing. Just kind of helps me to stay organized. Okay, so to find our m, we're going to do our y minus y. So if we choose 3 first, we're going to do 3 minus our y is 6 over, and since we chose 3 first for our y, we've got to choose -3 first for our x, minus, and then our x that goes with the other ordered pair is 6. Okay, so if we do 3 plus a negative or minus 6, that would be -3 over, and then same thing there. If we do -3 plus a -6, that would be -9, or you could do -3 minus 6, still -9. Okay, now if we simplify this out a little bit, well, I know a negative divided by a negative is going to be a positive, and then if I've got 3 over 9, I could pull a 3 out of both of those, and it would reduce down to 1/3. Okay, so I know my slope, or my m, is 1/3. Okay, so halfway there. Now I have to take that slope and use it to find my y-intercept. Okay, so I'm going to go y equals, and then my m I know is 1/3 x plus b, and then again I need to find an x and a y to plug in. Well, I can just use my numbers that I already had up here for my ordered pairs, right? So I'm going to use 6 and 6 because either way I plug them in, it's still 6. So my y is 6, and then I go 1/3 for my slope, and my x is also 6 plus b. So if I take 6 times 1/3, that should come out to be 2 plus b is equal to 6. Then to get rid of the 2, I'm going to subtract 2 from each side. So then I'll have 4 is equal to b. So I've got my b, got my m. Last thing I have to do is throw it together in an equation. So I would go y equals, my slope is 1/3 x plus my y-intercept is 4. And that would be your equation. Okay? The biggest thing with those is just making sure that you're plugging in the right things for the x and the y, because a lot of times people swap those around and put, you know, the x there and the y there, or they'll flop it around on the slope. A lot of little things you've got to pay attention to on that. Okay, so on page 15 in your book, there's example 3 that's kind of like a guided one where it kind of helps you to set up a problem just like this. So if I were you, I would try that out and see how you do. So I'd pause your video, try it out, and then see if you get the same answer that I get here. Okay, so the answer that they get in the book that you should have hopefully got is y equals 1/2 for the slope x plus, and then the y-intercept that they got is 7. So that's what it should say on your answer too. Hopefully you got to that. Okay, next thing here. Okay, so we are supposed to convert the equation 2x plus 5y is equal to 10 into slope-intercept form, and then we're supposed to take that and graph it. Okay, so 2x plus 5y is equal to 10. Write that down there. Okay, so when I'm trying to get to slope-intercept, so slope-intercept y equals mx plus b, the big thing is getting the y by itself. So basically I need to take the y and get that by itself. Okay, so what I'm going to start by doing is I'm going to start by getting rid of the 2x. So to get rid of 2x, I'm going to subtract 2x from each side. And that goes away, so then I'll have 5y is equal to negative 2x plus 10. And we remember that we can't combine those together and make it 8x because you can't do that with adding. Those are different, or not different. They're not like terms, okay? So this one has an x, this one doesn't. We can't combine them together to make 8x. We just keep them separate like that. And then to get rid of the 5y, well, they're right next to each other, so that means multiply. So we would do the opposite of multiplying, which would be dividing. So we're going to divide by 5 on each side. And we got to make sure that we divide everything over here by 5. So 5 divided by 5 comes out to be 1y, or just y. And then over here, taking all of those things divided by 5, it's going to be negative 2/5 x plus, and then 10 divided by 5 is 2. Okay, and I usually, instead of changing that to a decimal, which would be negative 0.4, I believe, usually slope is left as a fraction because it's easier to graph. Okay, so we always have to start with our y-intercept. So in this case, that's 2. So we're going to go over here on our y-axis to 2, stick a point, and then our slope is negative 2 over 5. So negative 2 over 5, our rise is on the top, run is on the bottom. The negative can either go with the top number or the bottom number. It doesn't matter, but it doesn't go with both of them. Okay, it goes with one or the other. So I put it with the negative 2, but you could have kept it a positive 2 and made it a negative 5. It doesn't matter. Okay, so negative 2 is for my rise, so that means I need to drop 2. And then my 5 is positive, so that means I need to go to the right 5. Okay, now if I was thinking about it the other way and having a positive 2 over a negative 5, well, to show it's the same way, I could go up 2, so 1, 2, and then left 5 for the negative. Oops, I didn't go over that one. That would still make a straight line through there, if I could draw a straight line. Okay, so you could go either way with that and be fine. Or you could have kept dropping, you know, go down another 2 and then right 5. Either way is fine. Okay, next problem here, example 5. So this is on page 16. Flip to it here. Okay, it's a story problem here, and they kind of ask us to do a lot of different things. Okay, so first thing it says, the maintenance crew at the Splash and Slide Water Park have found that their main attraction, the Big Kahuna Water Slide, needs some additional vertical bracing. There already exists a 10-foot vertical brace near the bottom and a 46-foot vertical brace near the top that is 72 feet from that bottom brace. 2 more vertical braces are needed that are equally spaced between those 2 braces. Model the slide with a line letting the bottom of the slide be the point 0, 10. Okay, they gave us a crap ton of information there, but they also gave us a picture, which is super nice. So I'm going to sketch out the picture here. The picture, I'm going to start with a graph. they tell me that the bottom of the slide is at 0, 10. Well, I can graph 0, 10 on a graph. So if I go, okay, 0 to the right and up 10, maybe we say it's somewhere in there. Okay, so that's the bottom of my slide at 0, 10. Now they tell me that the top of the slide is 46 feet tall, and I also have to go 72 feet over. So if I go over 72 feet and then up 46 feet, which we're just kind of estimating where all that stuff would be, that's the top of the slide. Okay, so that's the bottom of the slide there at 0, 10. The top of the slide, we had to go right 72 and up 46. So the top of the slide would be at 72.46. Okay, I'm going to draw my slide in here. That's my slide. Okay, and then they tell us there's these vertical braces here. So we've got one vertical brace that drops down at the beginning, another vertical brace that drops down there, and we know that this one's 46 foot tall, that one's 10 foot tall, and then they're going to add 2 additional braces in between here that are evenly spaced. I'm just going to kind of sketch those in as well. These are the 2 braces we're adding in. Okay, so let's look at what the questions ask. So there's an A and a B and a C. Okay, so for A it says, what are the possible coordinates of the top of the slide? Okay, well we just kind of figured that out there, didn't we? So we went over 72, up 46, so the top of our slide would be at 72.46. So for A, 72.46 possible coordinates. Now you also could have, I'm guessing why they say possible coordinates is maybe our slide went the other way, you know what I mean, kind of in this direction, so then it would be like negatives, but for our picture here and the picture they kind of have in the book, that point makes sense. Okay, and the next one says, find an equation for the line modeling the slide. Okay, so we need to find an equation for a line, and we know that the slide is going to cross here at 0, 10 and also at 72.46, so having 2 points, we can figure out a line, right, just like we were doing. So we want to start with slope. So if we did, our points are 72.46 and 0, 10. So if we do, we got x and y, x and y. So if we do y minus y, so one y is 46, the other y is 10, over our x's. So if we chose 46 first, we would have to choose 72 first, minus our x and the other one is 0. So if I did 46 minus 10, I'd have 36. 72 minus 0 is 72. And 36, I believe, is half of 72, so that should reduce down to a half. So if you take 36 divided by 36, you get 1. 72 divided by 36, you get 2. So our slope here is going to reduce down to 2. Okay, now using what we did before, y equals slope, our m is 1/2 x plus our b. Well, again, we need an x and a y. Well, we've got that in our ordered pairs. I'm going to choose 0 and 10 because they're smaller numbers. So my x is 0. So I've got 1/2 x is 0 plus b is equal to my y is 10. Plug in a 10 for the y. Then I solve that out for b. Well, this one's nice because if I take a half times 0, that's just 0 plus b is equal to 10, and 0 plus anything is just itself. So our b would be equal to 10. So that information right there, the m being 1/2, the b being 10, would give us our equation. Y equals our slope, 1/2 x, plus our y-intercept for the b is 10. That would be our equation. Okay. Now this next part here, they ask for C, how long should each additional brace be? Okay, so basically they want to know how tall that is and how tall that is. Okay, so one piece of information we're missing from our picture here is that we don't have how far apart these are, but it did tell us that the vertical braces are equally spaced. Okay, so if I've got 3 spaces here, and I know the total distance goes to 72, if I take that total 72 and divide it into 3 equal spaces, I know that each of those are 24 foot apart. Okay, so that's 24 foot there, 24 foot there, 24 foot there. Okay, because if I do 72 divided by 3, I get 24. That would give me equal spaces. Okay, so knowing that those are 24 is going to help us, because if I follow a straight vertical line up there, if that goes from 0 to 24 there, I'm up to 24 here for my x. So my x is 24. I just have to figure out my y for that point. Okay, same thing here. Well, I went 24 and then I went additional 24. That would be 48 over. So for my point there, I'm at 48 for my x, and I just have to figure out the y. Okay, and then the y will tell me how tall those braces are, which is what I want to know. So what I can do is I can use my equation that I just came up with. So y equals 1/2 x plus 10. And I'm trying to find y here, but I know what my x is. I know my x is 24, so I can plug a 24 in for the x. So 1/2 times 24 plus 10, and that'll figure out what my y is. Okay, so if I do half of 24, would be 12, plus 10 should come out to be 22. So my y would be 22 feet. For that one. And then for my next one there, same thing, I go y equals 1/2, and then this time my x is 48, so plug 48 in, plus 10, so half of 48 is 24, and then 24 plus 10 would be 34, so my y for the other one is 34 foot. Okay, and then that would also be, it'd be 22 there and 34 there in those ordered pairs. Okay, that's a pretty hands-on problem. There's kind of a lot going on with that, and really if you kind of mess up one step along the way, it's going to screw you for the rest of it. But hopefully you kind of got the hang of that and see how that kind of all intertwines together. Okay, so that's it for the notes. So for your assignment, you've got page 17, 2 to 18 even.